gaze upon the stars in the night sky, or the montage of celestial bodies, a question often arises: are we alone in the universe? This profound question has tantalized humanity for centuries, stirring our curiosity and fueling our exploration of the cosmos. Today we stand on the threshold of discoveries that may finally provide an answer. In our cosmic journey, we'll traverse the exciting realm of exoplanets, these mysterious worlds that orbit stars light years away from our own solar system. We'll delve into the tantalizing clues they offer about the potential for life as we know it, and even life as we can't yet imagine. We'll also explore the fascinating field of astrobiology, the science dedicated to understanding the potential for life beyond our own planet. We'll learn about the extreme forms of life that exist right here on Earth, and how they might guide our search for alien life forms on distant worlds. And of course, we'll look to the future, to the bold missions that aim to uncover the secrets lurking beneath the surface of Mars and the icy moons of Jupiter. These expeditions are not just flights of fancy, they represent humanity's relentless pursuit of knowledge and our enduring hope to find companionship in the vastness of the universe. In the grand tapestry of the cosmos, we find ourselves at a unique crossroads, armed with technology and scientific understanding that our ancestors could only dream of. We're peering deeper into the universe, searching for signals, for signs, for a hint that perhaps we are not alone. But the answers we seek are not just about satisfying our curiosity, they're about understanding our place in the cosmos. They're about realizing that even as we gaze upon the stars in wonder, they gaze back, holding the secrets to our biggest question. So, buckle up as we embark on this cosmic journey to unveil the secrets of life beyond Earth. Beyond our solar system, in the vastness of space, lie worlds unknown to us, the exoplanets. Exoplanets, by definition, are planets beyond our solar system, orbiting stars other than our sun. They're akin to cosmic neighbors, hiding in plain sight, masked by the dazzling light of their parent stars. Unveiling these mysterious celestial bodies is no easy task, yet our thirst for knowledge propels us forward. To find these elusive exoplanets, scientists have become cosmic detectives, employing a range of techniques. One of the most successful methods is the transit method. Picture this: you're gazing at a star, and suddenly, its light dims ever so slightly. This tiny dip in brightness may be a telltale sign of a planet crossing in front of the star, partially blocking its light. Just like that, we've potentially found an exoplanet. But finding these worlds is just the beginning. The real question is, could any of these planets be a home for life as we know it? This is where the concept of habitability comes in. A habitable planet doesn't just mean a nice place to live. It's a world where conditions might allow liquid water to exist on the surface. That's because water, as far as we know, is a key ingredient for life. Several factors play into this, including the planet's distance from its star, the so-called Goldilocks zone, its temperature range, and its atmospheric composition. But remember, just because a planet is in the habitable zone doesn't guarantee life. It simply means the conditions could be just right. Now, let's take a moment to spotlight some recent discoveries that have sent ripples of excitement through the scientific community. Last year, scientists announced the discovery of an Earth-sized planet in the habitable zone of a nearby star. This planet, named Proxima Centauri b, is just over 4 light-years away, a cosmic stone's throw in the grand scheme of things. And then there's the TRAPPIST-1 system, a compact family of 7 Earth-sized planets orbiting a dwarf star. 3 of these planets are located in the habitable zone, making them prime targets in the search for potential life. These are just a handful of the over 4,000 exoplanets that have been discovered to date. Each one is a new world, with its own unique story to tell. Some of these worlds are gas giants, dwarfing even Jupiter, while others are rocky worlds similar in size to Earth. Some orbit incredibly close to their stars, boasting scorching temperatures, while others languish in the frigid outskirts of their systems. The diversity of these exoplanets challenges our understanding of planetary formation and evolution, expanding our perspective of what a planet can be. And with each new discovery, we inch closer to finding an answer to that age-old question. Are we alone in the universe? New telescopes and missions are on the horizon, ready to take up the mantle in our exoplanet hunt. Each one will delve deeper into the mysteries of these distant worlds, bringing us closer to understanding our place in the cosmos. These incredible discoveries bring us one step closer to answering the profound question, are we alone? Astrobiology, a field dedicated to finding life elsewhere, opens up a world of possibilities. In the vast cosmic arena, astrobiology seeks to answer one of humanity's oldest questions. Are we alone? But before we can detect life in the cosmos, we first need to understand what it means to be alive. Life, as we know it, thrives in a variety of conditions on Earth. From the scorching desert sands to the icy Antarctic, from the deepest oceans to the highest mountains, life finds a way. But some life forms on our planet, known as extremophiles, take this to another level. Thermophiles, for instance, thrive in extreme heat, while halophiles flourish in high salt conditions. These hardy organisms challenge our traditional understanding of habitability and inspire us to broaden our search for life beyond Earth. As we look to the stars, we use these extremophiles as a basis to imagine what kind of life could exist in the harsh conditions of other worlds. Perhaps somewhere out there in the cosmos, there are beings that thrive in methane lakes, under crushing atmospheric pressures, or even in the radioactive cores of distant planets. But how exactly do we search for these hypothetical life forms? Well, we look for what scientists call biosignatures. These are indicators of life that might be detected through scientific observation or experimentation. They could be anything from complex organic molecules, certain patterns in the distribution of elements, or even gases in a planet's atmosphere that hint at biological activity. For instance, oxygen is a potent biosignature. On Earth, oxygen is constantly replenished by plants and photosynthetic bacteria. Without them, our atmosphere's oxygen would quickly react with other elements and disappear. So if we find a planet with a lot of oxygen in its atmosphere, it could be a sign that there's some form of life there producing it. Similarly, methane is another powerful biosignature. On Earth, methane is produced by both geological and biological processes. However, the methane produced by life, such as cows, termites, and even some types of bacteria, is chemically distinct from the methane produced by non-biological processes. So, if we detect this type of methane in the atmosphere of another planet, it could be a sign of life. The search for biosignatures is a complex and meticulous process. It takes high-powered telescopes scanning the skies, sophisticated instruments analyzing light from distant stars, and teams of dedicated scientists interpreting the data. But the payoff could be monumental. Discovering a biosignature would not only transform our understanding of life's place in the universe, but also challenge our perceptions of what it means to be alive. However, it's important to remember that a biosignature is not definitive proof of life. It's merely a sign, a clue that life might exist. To confirm life's existence, we'd need to study the potential living things directly, either by bringing samples back to Earth or by sending rovers or probes to other worlds. And that's precisely what we're doing. Right now, we have rovers on Mars looking for signs of past or present life. In the future, we hope to send missions to the moons of Jupiter and Saturn, where we suspect there might be oceans beneath the icy surfaces. These missions could uncover the tantalizing evidence we're looking for, or they could raise even more questions. In the quest for life beyond Earth, every discovery is a step forward, every question a spark of curiosity, every possibility a beacon of hope. As we continue exploring the cosmos, we carry with us the audacity of imagination, the courage of curiosity, and the determination to seek answers. These biosignatures could be our first clues to finding life beyond our home planet. And who knows? Maybe one day we'll finally answer the question, are we alone in the universe? Our quest for answers has led us on thrilling missions across the solar system. Indeed, the allure of the unknown has always been an irresistible siren song to us humans. As we speak, rovers like Perseverance are trundling across the rugged terrain of Mars, our red neighbor. These robotic explorers are not just taking a leisurely stroll, they're on a mission of profound significance to find signs of past or present life. Perseverance, for instance, is equipped with a suite of scientific instruments designed to explore the geology of Mars and analyze its climate. But its most exciting task? Hunting for biosignatures, signs of microbial life that could have existed in the planet's past. After all, Mars was once a wet world, with rivers, lakes, and even an ocean. Could life have taken hold there? We're on the brink of finding out. But Mars isn't the only intriguing destination in our solar system. Allow me to introduce you to Europa, one of Jupiter's largest moons. Beneath its icy surface lies a vast subsurface ocean that contains more than twice the amount of water found on Earth. This makes Europa an incredibly tantalizing place in the search for extraterrestrial life. Imagine a world where life exists not under the warmth of a sun, but in the dark depths of a global ocean, warmed by the tidal forces of its parent planet. It's a thought that sends shivers down the spine, isn't it? To explore this icy moon, NASA is developing a pioneering mission known as the Europa Clipper. Slated to launch in the next decade, this spacecraft will carry out detailed reconnaissance of Europa's surface and subsurface to understand the moon's ice shell and the subsurface ocean beneath. It's a daunting task, but one that could potentially answer the question, could life thrive in such extreme environments? But the exploration doesn't stop there. We're also preparing for the ambitious Mars Sample Return mission. This will be the first mission to bring samples from Mars back to Earth. These samples, carefully selected and packaged by the Perseverance rover, will provide invaluable information about the Martian environment and its potential to host life. It's a mission that's as audacious as it is exciting. It involves several spacecraft, an intricate dance in space, and a landing back on Earth. But the potential payoff is enormous. The samples returned could provide definitive proof of past life on Mars, or clues about the planet's geological history that we cannot currently understand from afar. These missions, exploring worlds both familiar and alien, are our best bet yet at uncovering the secrets of life beyond Earth. They exemplify our relentless curiosity, our thirst for knowledge, and our undying hope that we might not be alone in this vast, beautiful universe. So as we reach for the stars, we're not just exploring new worlds. We're also exploring what it means to be human, to be a part of this cosmic tapestry, and to seek our place in it. These missions are our best bet yet at uncovering the secrets of life beyond Earth. The search for life beyond Earth is a complex puzzle, with pieces scattered across the cosmos. We're at the cutting edge of a grand cosmic journey, one that spanned not only our lives, but the lives of our ancestors. It's a journey that asks the enduring question, are we alone? We've ventured into the realm of exoplanets, those tantalizing worlds beyond our solar system, explored the potential for life beyond our blue marble, and embarked on missions reaching for the stars. We've seen how scientists are using innovative techniques to uncover these distant worlds, and how astrobiology is guiding our search for potential life forms. Astrobiology has shown us that life on Earth is incredibly adaptable, thriving in the most extreme environments. This gives us hope that life could exist in the seemingly inhospitable worlds beyond our own. From the potential microbial life on Mars to the promising subsurface oceans of Jupiter's moon Europa, our understanding of where life can exist continues to grow. Looking forward, the future of exploration holds immense promise. The extremely large telescope, aptly named, will be the world's biggest eye on the sky, capable of collecting more light than any telescope before it. With its unprecedented power, we'll be able to delve deeper into the cosmos, revealing secrets about exoplanets, and perhaps even finding signs of life. Yet despite our technological advancements and scientific breakthroughs, the question remains, are we alone in the universe? It's a question that's been asked by countless generations before us, and one that will continue to be asked by generations to come. As we reach further into the cosmos, we inch closer to finding an answer. The mysteries of the universe are vast and complex, but they are not beyond our comprehension. We are part of this universe, and as we continue to explore, we may just find that we are not alone. As we continue to explore the universe, the question remains, are we alone? Only time will tell. Until then, keep looking up and stay curious about the universe we inhabit.